Hello, my terrific Algebra 3 students. We are ready to take a trip and visit the ellipse. How does an ellipse look? It is oval shaped. See the part on the outside here that I'm tracing? That is the oval shape. We'll talk more about the focus points later, but this is the oval shape. The ellipse is one of our four conics. The four conics will be the ellipse, the circle, the hyperbola, and the parabola. We've talked about the circle. We've talked about the parabola. So we're going to be talking about the ellipse today. We take a plane and we slice the cone to get these four different conic sections. You can think of real world examples of an ellipse, like a football is shaped like an ellipse. The orbits of the planets are in the shapes of an ellipse. And we have in Washington, D.C., there is a room that's called the National Sanctuary Hall, and it is elliptical in shape. We are now ready to name the parts of the ellipse. Here is an ellipse. We have the center. The longer axis is called the major axis. The other axis is called the minor axis. And along the major axis, we'll always have the vertex points and the focus points that we'll talk about later. The other vertices along the minor axis are called co-vertex. But remember that the vertices and the focus points are always on the major axis. Here is an ellipse where the major axis is horizontal. See, that's the longest axis. Center at the origin. Here is an ellipse where the major axis is vertical. Again, the center is at the origin. You may ask the question, well, how can I tell if the major axis is vertical or horizontal? Well, here we have the standard equations of an ellipse. And notice that the a square is always larger than the b square. In other words, the larger denominator is always the a square. The larger denominator is always the a square. So here is an ellipse where the major axis is horizontal. You see the a square, which is the largest denominator, is under the x variable. Think about the x-axis. The x-axis goes from left to right, so the major axis is horizontal. Over here, notice that the a squared is under the y term, the y-squared term. Remember again that a squared is always larger than the b squared. So since the a squared, which is the largest denominator, is under the y variable, then the major axis is going to be vertical, which is what you see right here. And if you go back and look at the major axis here, which is horizontal, from the origin to this point right here is A. From the origin to this point is also A. So the length of the major axis is going to be 2A. And the length of the minor axis will be what? 2B. So you see, here's the vertical major axis. From the center, here is A. From this center, this distance is A. So it's going to be 2A for the major axis and 2B for the minor axis. We are now going to answer 7 questions about an ellipse. And the ellipse that we're looking at is x squared divided by 9 plus y squared divided by 4 equals 1. Remember, you always have to have a 1 here when you have what? This ellipse. I wrote this equation again to show you that I have the a squared under the x squared. How do I know this? Because the larger denominator will always be the a squared. The larger denominator will always be the a squared. Now, the first question that I'm going to ask, is the major axis horizontal or vertical, and why? Well, when you look at this, you see the larger denominator is 9. It's under the x variable, and you think about the x-axis going from left to right, so that the major axis then is going to be what? Horizontal. The major axis is going to be horizontal. Then the center of the ellipse, nothing is being subtracted from the x, nothing is being subtracted from the y, so the center will always be the origin. Always the origin when nothing's being subtracted. Okay, the third question that I'm going to ask is, what is the a squared? Well, remember the a squared is always the larger denominator. So the a squared is equal to 9. And if you take the square root of both sides, you get a to be plus or minus 3. But we're talking about a distance, so the a is 3. I'll talk about the minus part in just a little bit here. So the a is 3. And again, here is our equation. The b squared is going to be 4. So over here, I put my b squared is equal to 4. And then if I take the square root of that again, I'm going to get plus or minus, what, 2. But we're talking about a distance, so the b is what, 2 units. And then I'm going to ask for the length of the major axis. Well, remember the a was what, 3. And the length of the major axis is always 2 times the a. So it's going to be 2 times 3, which is 6 units. So the length of the major axis is 6 units. It's always 2 times the a. The length of the minor axis, remember that's the b. And the b was equal to what? 2. And the 2 times the b will be equal to the length of the minor axis, will be 2 times 2, which is equal to what? 4. So that's the length of our minor axis. That was the 6th thing that I was asking. Now, the 7th and final thing that I'll ask is to sketch this. The first thing we do, we always put a point at the center. Our center is what? The origin. Since our major axis is horizontal and the a is equal to 3, from the center, we're going to move 3 units on the x-axis and 3 units on to the left of the center. See, that's where the plus or minus comes from. And remember, the b was equal to what? 2. So from the center, I move up 2 units, and I move down 2 units. Then what I'm going to do, I'm going to put a little closed dot on the outside, moving from the center. And then what I'm going to do is I'm going to do a dot to dot. See, I'm going to make my oval shape. And this is the sketch of our ellipse. Remember that you can stop, pause, and rewind to review anything in this video. Again, stop, pause, rewind to review. We are going to have a homework assignment that I will give you. It's going to also be posted in PLUS portals. But here is this homework assignment that I will post there. So I hope that you have enjoyed our trip today talking about the ellipse. And we'll be talking more about the ellipse later.